Hi there, this video is going to go through some of the acid-base reactions, and then this should be covered in your acid booklet, which is booklet number 3, about page 12, all the way down there. So let's just start. So what we need to know from VCAR is the reactions of acids with 3 things: with metals, with carbonates and hydroxides. We need to know how to do balanced, full and ionic equations with states. So we've done balanced equations, we've done full equations, ionic equations and states. We've probably already done some of these before, and so what we're doing is we're just saying, okay, if I react an acid with one of these materials, what am I going to get? So in particular today we're going to start with hydroxides, then carbonates, and then metals. So we're going to go backwards. So the first one we've got is an acid plus a metal hydroxide. That is a classic acid-base reaction. Why do I say it's a classic acid-base reaction? Is because a hydroxide ions are what make things basic. So that's why we know that that's an acid-base reaction. The next one we've got is an acid and a metal carbonate. Again, quite similar, except we've definitely got a big difference here in the fact that we're now talking about carbonate. So that's your key there. The last one is an acid plus a metal. So it's not acid-base, it's actually a redox reaction, and we are going to cover redox reactions not too far down the track, but we'll just do a really brief introduction to what you get between an acid and a metal. So to begin with, my first type of reaction is an acid plus a metal hydroxide. So taking one of our acids from our list, so from our list of acids, so this could be HCl like it is in this equation, it could be HNO3, it could be nitric acid, it could be H2SO4, anything like that, any acid at all. We're going to add that to any kind of metal mixed with hydroxide. So in this case, we're looking at calcium hydroxide. You need to know that this metal and hydroxide is an ionic compound, so you should be able to figure out your formulas based from the numbers there. When you mix them together, you get 2 products. You get a salt and you get water. So think about where the water is going to come from, because that's the one that you can always figure out. So the water is H2O, and I'm going to ignore the balancing. So it takes an H from here and the OH is from here and pulls them over. And so what happens with my salt then is my salt is metal plus the non-metal, because it's an ionic compound. Oh, that's the wrong way around, but you get what I'm doing. So it's very similar to those precipitation reactions where you mix those 2 things together. So when you are going to write this as an ionic equation, these remain aqueous, so they kind of get ignored. Hang on, I wonder if I can undo. No, I can't. So these ones are remaining aqueous, but wherever we've got a change in state, we're going to have to, actually, I'm just going to do that again. So let's clear that pen marking just to make this a bit easier. Let's explain why this is the ionic by writing it out underneath. So because this is aqueous, we can split this out, plus 2Cl minus, aqueous, plus Ca2 plus, aqueous, plus 2OH minus, aqueous, goes to Ca2 plus, aqueous, I'm running slowly out of space, 2Cl minus, aqueous, plus 2H2O liquid. Okay, so because it's a liquid, we're not going to split them. So let's make sure we can cross off our spectator ions. So I can see that I've got chlorine on this side, I've got chlorine on this side, calcium on this side, calcium on this side. And what we get left with is 2H plus aqueous plus 2OH minus aqueous goes to 2H2O liquid. Now, because it's got the same coefficient in front of all of those, I can actually even just get rid of those coefficients. So that get rid of those 2's, and that's why we ended up with this ionic equation here. Okay, so when you're doing your acid plus a metal hydroxide, you write down your acid, you write down your metal hydroxide formula, then you create your salt. The salt is always aqueous as well, and then you create water, and the water is the liquid. So in this case, we've got this ionic equation. You've got these spectator chlorines, these spectator calciums, and the whole point is that the H plus from the acid and the OH minus from the hydroxide, metal hydroxide, that base, are going to create the water. And that makes sense, doesn't it? Because now we've got an acid and a base, and they neutralize each other. Let's have a look at the next one. The next one is acid plus a metal carbonate. So very similar equation we're looking at here. We're going to start with HCl, and we're going to start with calcium carbonate. The calcium part is going to go to this salt. The back part of my acid is going to go to this salt. And so what we've now got is we've got these hydrogens, we've got some oxygens. So they're going to come over and go to my water. But then in addition to that, hang on, let me just change my color. In addition to that, because I've got this carbonate kind of group here, it makes something else. It makes carbon dioxide gas. So let's just see if we can write out our dissociated equation, and then we'll end up with our ionic equation. So let's write them all out. I'm going to try and give myself more space this time. 2H plus aqueous plus Cl minus aqueous, that's two of them as well. Remember, anything that's aqueous is what I can turn into an ion plus CaCO3 solid. So that one stays as an element, or sorry, as a compound. Then we've got Ca2 plus aqueous plus 2Cl minus aqueous plus H2O liquid plus CO2 gas. Okay, now we're going to go through and we're going to find where our spectator ions are. The only spectator ions I have are the chlorines. So then I rewrite 2H plus aqueous plus CaCO3 solid plus goes to Ca2 plus aqueous plus H2O plus CO2. Okay, so when you're writing your ionic equations, remember that you just break apart anything that is aqueous, and then you can cancel out your spectator ions. The final one that we get is acid. Oh, sorry, that's not meant to be acid plus a metal carbonate. It's just meant to be acid plus a metal. So if you add acid to a pure metal, then what you will get is a salt again. So that metal is going to bond to the other half of the. So the chlorine comes from here in the salt, from the acid, and the magnesium comes from just the metal that's in the solution. And then all you've got left behind us here are two hydrogens. So that's where they're going to go. So let's make sure that we get our ionic equation done. So anything that's aqueous is going to be split. So 2H plus aqueous plus 2Cl minus aqueous plus MgS goes to Mg2 plus aqueous plus 2Cl minus aqueous plus H2 gas. Let's make sure we go through. Let's cross off. I like red today. Let's cross off my spectator ions. I can see there's chlorines on this side, chlorines on that side. Nothing else is the same. Mg solid is not the same as Mg2 plus aqueous, because one is a dissolved ion. So we should end up with 2H plus aqueous plus Mg solid goes to Mg2 plus aqueous plus H2 gas. And when we have a look, yay! There is my ionic equation. So here is just a list down the bottom to help you out. These are our common acids and their conjugate bases. So our common acids, we use a lot of these guys, these HCl, H2SO4 and HNO3. Then you can have just a hydronium ion by self-ionized water. And then you've got the other ones for the diprotic and triprotic. So that's the conjugate base HSO4 minus is my one step down the diprotic pathway. This one here is phosphoric acid. So that one there is phosphoric acid. We've got hydrogen fluoride here, or hydrofluoric acid. Then we've got ethanoic acid or acetic acid. Then you've got like a hydrogen carbonate, hydrogen sulfide, water, all the way through down to here. So these guys down here, they're mostly negligible acids. They're not really going to cause much of an issue. Whereas over here, you can see I've got very strong bases or anything that is a hydroxide or an oxide. So if you have calcium oxide, it's going to be quite a strong base. Calcium hydroxide, still a strong base. And so hopefully they can help you out when you're answering these questions.